Welcome to Maths Academy Tube. In this video, I will try to touch every subtopics in the set of complex numbers. So if you are new for this channel, don't forget to like and subscribe my channel. Which of the following is the simplest form of the given complex number here? We are asked the simplest form of this complex number. So I will show you the simplest form of the given complex number. So it's given that 4 minus 3i over 3 plus 4i plus 1 minus 2i, the conjugate of 1 minus 2i. So just to remind you some of the things from the complex number, the conjugate of x plus yi is given by x minus yi. Okay, so this is what we mean by conjugate of a certain complex number. So this the given complex number can be written as 4 minus 3i over 3 plus 4i plus 1 plus 2i. Okay, the imaginary part will change its sign. Okay, if this is plus, here it becomes minus. Whenever we have x minus yi, its conjugate becomes x plus yi. Okay, this is the conjugate. So we need to simplify this thing, the rational part. So using the simplification, we can write that 4 minus 3i over 3 plus 4i can be simplified to in this form. We multiply both the numerator and the denominator by the conjugate of the expression in the denominator. So we write like this, okay, plus 1 plus 2i. Now let us multiply the things that we have here. Let's multiply them. So using multiplication of complex number, we multiply 4 by 3 first. 4 times 3 minus 4 times 4i minus 3i times 3 plus 12i square over 3 square plus 4 square. The denominator becomes 3 square plus 4 square. This part, the product of this part is 3 square plus 4 square. Why? For example, if we have two complex number, x plus yi times x minus yi, the product of this thing is always x square plus y square, as you can check. So here we do have 1 plus 2i, 1 plus 2i. Then let us write this one. 4 times 3 is 12 minus 16i minus 9i minus 12. I square is minus 1 because I is square root of minus 1. So in place of I square, you can substitute minus 1 over 25. Over 25. 3 square plus 4 square is 25. Now this minus 12 with positive 12, it will be eliminated. Okay, so the result becomes minus 25i over 25 plus 1 plus 2i. Now this 25 can be simplified to minus I plus 1 plus 2i. The result is minus I plus 2i is I plus 1, or 1 plus I will be the simplified form of the given complex number. Therefore, our answer will be A. Which one of the following is the simplest form of the modulus of 3 plus 4i minus 25i over 3 plus 4i? So This is also another question related with simplification of complex number. So the question is the modulus of 3 plus 4i minus 25i over 3 plus 4i. So here I want to remind you what the modulus is mean. The modulus of a complex number, the modulus of a complex number x plus yi is defined as square root of x squared plus y squared. So here we have the modulus of 3 plus 4i. So this is obtained by square root of 3 squared plus 4 squared. The result is a square root of 25, which is 5. So in place of the modulus of 3 plus 4i, we can substitute 5. So use 5 minus 25i over 3 plus 4i. We need to also simplify this part. This part requires further simplification. We simplify it by multiplying both the numerator and the denominator by 3 minus 4i over 3 minus 4i. Okay, we multiply both the numerator and the denominator in this form to write in more simplified form. So this becomes 5 minus 25i into 3 minus 4i over 3 square plus 4 square. You know, this part, the product of the things in the denominator, this part is 3 square plus 4 square. So here, for any complex number x plus yi times x minus yi, the product of any complex number with its conjugate is written as x squared plus y squared. So you need to know these things so that you can minimize the time taken to solve or to simplify this, the given simplified form of a complex number. So now let us substitute everything here. 5 minus 25 here, 5 minus 25i into 3 minus 4i over 25, because 3 square plus 4 square is 25. Now you can simplify this 25. The result becomes 5 minus I into 3 minus 4i. So this means 5 minus 3i plus 4i squared. Now I square is, in place of I square, you can substitute minus 1 because I is a square root of minus 1. So I square is minus 1. So this becomes 5 minus 3i minus 4, which is 1 minus 3i. So the simplified form of the given complex number is 1 minus 3i. Therefore, the answer for this problem will be D. 1 minus 3i is the answer. In the set of complex numbers, the solution set of x squared minus 2x plus 5 is equals to 0 is what? So here we are asked the solution set of a certain quadratic equation in the set of complex number. We know that for any quadratic equation, ax squared plus bx plus c is equals to 0 has a solution in complex number. Okay, any quadratic equation has a solution in complex number, but this may not work for the case of real number. So here we use the formula for quadratic. The equation is x squared minus 2x plus 5 is equals to 0. So the a value is 1. b is minus 2, and c is 5. So we will apply the formula for the solution of quadratic equation. Minus b plus or minus b squared minus 4ac over 2a. So minus b is minus 2 plus or minus square root of minus 2 square minus 4ac. A is 1, c is 5, b is minus 2 over 2a. Okay, so the solution becomes x is equals to minus of minus 2 is positive 2 plus or minus square root of minus 2 square is 4 minus 4 times 1 times 5 is 20 over 2. This means 2 plus or minus square root of negative 16. Okay, square root of negative is possible in the set of complex number. So this becomes 2 plus or minus square root of 16 times minus 1 over 2. Now this 16 can be taken out from the radical. It becomes 2 plus or minus 4 radical minus 1 over 2. But radical minus 1 is I. So the given solution becomes 2 plus or minus 4i over 2. This means 2 is common for both 2 and 4. This means x becomes 2 over 2 plus or minus 4i over 2. So our x value becomes 1 plus or minus 2i. Therefore, the solution set for this quadratic is 1 plus 2i and 1 minus 2i are the solution set. Therefore, from the given choice, our answer will be C. Let z be a complex number. Which of the following is the solution set of the given equation consisting of complex number? So here is the procedure. The equation is z cube minus iz is equals to 0. This means you can factor out the common things, then z squared minus I is equals to 0. So the product of this thing will be 0 whenever z is 0, or z squared minus I is 0. This means z is equals to 0 or z squared is equals to I is the solution. But we need to write this z squared is equals to I. This will have another solution. So let us find the solution for z squared is equals to I. We know that z is a complex number. So let z is given by a certain complex number a plus bi. Then z squared becomes a plus bi square. You can square or you can multiply a plus bi with itself. The result is a square minus b square plus 2abi. Okay, this is our z square. Now z square is exactly the same as I, so this implies a square minus b square plus 2abi is equals to I. I means 0 plus I. Okay, the real part is 0 and the imaginary part is 1. So from this we can get that a square minus b square is the real part for the left hand side, and 0 is the real part for the right hand side, and the imaginary part is 2ab on the left hand side and 1 from the right side. So this implies a square is equals to b square, and b can be written as 1 over 2a. Now let us search the value of a and b from these two equations. So a square is equals to b square, but b is 1 over 2a. So a square becomes 1 over 2a the whole square. This means a square is equals to 1 over 4a square. Now you can use crisscross. Whenever you crisscross, you will get a for a the power of 4 is equals to 1. This means a square is equals to 1 over 4. I mean a the power of 4 is 1 over 4. Dividing both sides by 4, you will get a the power of 4 is 1 over 4. This implies a square is equals to 1 over 2. So our a value becomes plus or minus 1 over radical 2. This is the a value. We know that b is 1 over 2a. So you can get b is equals to plus or minus 1 over 2 times a means, or avoid this plus or minus, 1 over 2 plus or minus 1 over radical 2. So whenever you rewrite this thing, it becomes plus or minus radical 2 over 2, or b can be written as plus or minus 1 over radical 2. Okay, so the other forms of writing b is plus or minus 1 over radical 2. So both a and b are similar. So the z value becomes z is a plus bi. Therefore z becomes a is plus or minus 1 over radical 2 plus I times b is plus or minus 1 over radical 2. So there is something in common. Plus or minus 1 over radical 2 is common. Then inside it becomes 1 plus I. Therefore we have three solutions. Z is equals to 0 and z is equals to this one. Therefore the solution set for this complex equation is 0 and plus or minus 1 over radical 2 into 1 plus I. This is the solution set for the given complex number. So our answer will be D. If z is 3 plus I over I minus 2, if this is our complex number, this is given, and the required thing is the conjugate of z. So let us write it. Z is 3 plus I over I minus 2, and we are asked the conjugate of z. Okay, so to remind you the conjugate, if z is given in a standard form, if z is a certain complex number which is written in this form, if this is z, if z is written in a standard form, its conjugate denoted by z bar is given by x minus yi. And we have also some properties of conjugates. Here I will tell you the properties and the other forms of writing the given complex number. So we are asked z conjugate. Z conjugate means 3 plus I over I minus 2 conjugate. Okay, from the properties, if we have a certain ratio of two complex number, the conjugate of the ratio of the two complex number is given by z1 conjugate over z2 conjugate. So we will apply this property. So here it becomes 3 plus I conjugate over I minus 2 conjugate. Okay, so by definition the conjugate will change only the sign of the imaginary parts. Therefore it becomes 3 minus I over minus I minus 2. Here you need to be very careful in determining the conjugate of I minus 2. It's minus I minus 2. So this can also be written as the negative. You can factor out negative from the numerator. It becomes minus plus I. And whenever we factor negative from the denominator, it becomes I plus 2 or 2 minus I. Now negative by negative, it becomes minus 3 plus I over I plus 2 or 2 plus I. Therefore, the conjugate of the given complex number, the conjugate of this complex number is expressed in this form. You can also rewrite this thing in different ways. For now, this is the conjugate of the given complex number. So from the given choice, our answer will be A. What are the values of u and v that satisfy the given equation? So let's take the equation as it is, then we will determine the values of u and v satisfying the given equation u plus 3i over 4 minus 2i is equals to 2 plus vi over 20. Okay, so you can use different ways, but for me, I'm going to take a crisscross. So 20 times u plus 3i is equals to 4 minus 2i times 2 plus vi. Now let us directly multiply everything. Here 20 times u is 20u plus 60i is equals to 4 times 2 is 8 plus 4 times v is 4vi. 2i by 2 is, there is minus 4i, minus 2i times vi is plus 2v, because minus 2vi becomes plus 2v. Here you should remember I square is minus 1. So now let us collect like terms. 20u plus 60i is equals to collecting terms containing I and I free variables. I mean 8 plus 2v plus 4v minus 4i. Now these two complex numbers are equal if they have the same real and imaginary parts. That means 20 must be the same as 8 plus 2v. So by the equality of two complex number, 20u must be the same as 8 plus 2v. At the same time, their imaginary part must be the same. The imaginary parts are 60 is the imaginary part for the left hand side, and 4v minus 4 is the imaginary part for the right hand side. So let us solve this thing. 60 is equals to 4v minus 4 means you can take this to the left. So 60 plus 4 is equals to 4v. 64 is equals to 4v. Dividing both sides by 4, v becomes 64 over 4, which is 16. The value of v is 16. Now use v here. So 20u is equals to 8 plus 2v means 8 plus 2 times v, which is 8 plus 32. 8 plus 32 is 40. 20u is equals to 40 means dividing both sides by 20, we will get u is equals to 40 over 20, which is 2. So the value of u is 2 and v is 16. Therefore, the values of u and v from the choice is in C. If z is given by 2 minus 4i over 1 plus I, then the modulus of the conjugate of z is how much? Here I want to remind you the modulus and the conjugate. Actually, I told you what the modulus and conjugate is mean. Just to remind you once again, if we have a certain complex number x plus yi, the modulus of z is denoted by this absolute value symbol, and it's defined as x squared plus y squared, and the conjugate of any complex number is given by x minus yi, where z is x plus yi. So we will apply these definitions and formulas to determine the modulus of the conjugate of 2 minus 4i over 1 plus I. Now, to simplify things, the modulus of the complex number and the modulus of its conjugate are the same. Okay, this is one of the property of modulus. So if this is true, we can simply calculate the modulus of z to determine the modulus of its conjugate, which is denoted by the modulus of 2 minus 4i over 1 plus I. So from the properties of modulus, you can take separately the modulus of 2 minus 4i over the modulus of 1 plus I. Okay, so you need to know for any two complex numbers z1 and z2, where z2 is non-zero, the modulus of z1 over z2 is the same as the modulus of z1 by the modulus of z2. So apply this thing. So the modulus of the numerator becomes square root of 2 square plus minus 4 square over the modulus of 1 plus I means square root of 1 square plus 1 square, which is square root of 4 plus 16 over square root of 2. So the result is square root of 20 over square root of 2. You can take the radical together. So the result is radical 10. So the modulus of the given complex number is radical 10. Therefore, our answer will be A. If z1 is 2 minus I over 1 plus I, and z2 is 1 plus I over 1 minus I, then what is the value of z1 plus 2 times z2? So it's very simple. Let us take the given values as it is. z1 plus 2 times z2 is the same as 2 minus I over 1 plus I plus 2 times z2, which is 1 plus I over 1 minus I. So this is the same as 2 minus I over 1 plus I plus 2 plus 2I over 1 minus I. Now we have to take each of them separately. We need to simplify. We need to take the simplified form for each of them separately. So when we take 2 minus I over 1 plus I, the simplified form of this one is 2 minus I times 1 minus I over 1 plus I times 1 minus I. So the simplified form of this is 2 minus 2I minus I plus I square means minus 1 over 1 square plus 1 square. Don't forget that the product of any two complex number with its conjugate x plus yi times x minus yi, this is the same as x squared plus y squared. So I will use this fact in the denominator. So this becomes 1 minus 3i over 2. Okay, only this part is 1 minus 3i over 2. Again, let us simplify this part. So 2 plus 2i over 1 minus I can be simplified by 1 plus I over 1 plus I. So let us directly multiply everything here. It becomes 2 plus 2i plus 2i plus 2i square means minus 2 over 1 square plus 1 square. So this is the same as 4i over 2, or you can say 2i in general. So the sum of these two, let us take the sum of these two. Okay, that means 1 minus 3i over 2 plus 4i over 2. This is 1 plus I over 2. Therefore, the simplified form of the given complex number is 1 plus I over 2. So our answer will be B. If z is given in the form of polar form, this way of expressing a complex number is called polar form. There are two ways of expressing a complex number. One is the Cartesian form, the other is polar form. So a certain complex number is given in polar form. The question is z to the power of 5. Here you shouldn't waste your time by multiplying the given complex number 5 times. There is a rule. If we have a certain complex number which is written in polar form, r into cos theta plus I times sine theta, if this is our complex number, z to the power of n becomes r to the power of n times cosine of n theta plus I times sine of n theta. We use this fact. So z is given. Z is already given as cosine of pi over 10 plus I times sine of pi over 10. R is here 1. So this becomes z to the power of 5 is equals to cosine of 5 pi. You will multiply the thetas by 5 pi over 10 plus I times sine of 5 pi over 10. So 5 pi over 10 means pi over 2. So this becomes cosine of pi over 2 plus I times sine of pi over 2. But you need to know the cosine and sine of some standard angle. Cosine of pi over 2 means cosine of 90 degree. Cos 90 degree is 0. Okay, cos 90 degree is 0. And sine 90 degree is 1. So it becomes 1 times I. The result is I times 1 or 1 times I. So the given complex number, z to the power of 5, z to the power of 5 becomes, therefore z to the power of 5 becomes I. So our answer for this problem is C. Let z is 1 minus I over 1 plus I. Then what is here? Z is something the power of 18. Then what is z? We are asked the simplified form of the given complex number. So here we need to be very technical. Z is given as 1 minus I over 1 plus I. You shouldn't waste your time by multiplying the given expression 18 times. The only thing that we can do is we take the simplified form of 1 minus I over 1 plus I. We simplify this thing. Okay, we simplify this expression. Then we evaluate the simplified form of the given expression by the power of 18. So let us simplify or write this thing in another form. It becomes 1 minus I over 1 minus I is the simplified form, or the way to simplify the given expression. Therefore, it becomes 1 minus I plus I square over 1 square plus 1 square. So this means 1 minus 2I plus minus I square is minus 1 over 2. Now minus 1 with 1 is 0. Therefore, the result is minus 2I over 2. So the simplified form of this inner expression is minus I. So z becomes, here z becomes minus I the power of 18, which is the same as I the power of 18. I the power of 18 means I the power of 16 times I square, but I is square root of minus 1. This implies I square is minus 1. I the power of 4 is minus 1 square, which is 1. So I the power of 4 is minus 1. I mean positive 1 means I the power of 16 is also 1. So in place of here, substitute 1. 1 times I square, which is 1 times minus 1. I square is minus 1. Therefore, the whole this thing becomes minus 1. So the simplified form of the given complex number is minus 1. If z is given in polar form, here radical 2 times cos pi over 12 plus I times radical 2 times sine pi over 12, then what is the value of z cube? We are asked the value of z cube in terms of polar form. So let us write the given complex number, the original complex number. Z is equals to radical 2 cosine of pi over 12 plus I times radical 2 sine of pi over 12. We have radical 2 in common, so we can take it out. Radical 2 into cosine of pi over 12 plus I times sine of pi over 12. So we are asked this one. This is the z value. Z is radical 2 into cosine of pi over 12 plus I times sine of pi over 12. So this is the better way to write the given complex number in polar form. So the question is z to the power of 3. Z to the power of 3, as I have told you before, for a certain complex number z is equals to r times cos theta plus I times sine theta. Z to the power of n means r to the power of n into cosine of n theta plus I times sine n theta. This is De Moivre's law. So z cube is equals to radical 2 the power of 3 times cosine of 3 pi over 12 plus I times sine of 3 pi over 12. Okay, this is the other forms of z cube. So z cube is equals to radical 2 cube means 2 radical 2, which is 2 radical 2 into cosine of pi over 4. 3 pi over 12 means pi over 4 plus I times sine of pi over 4. But sine pi and cos pi, I mean sine pi over 4 and cos pi over 4 are the same, and their values is 1 over root 2 or root 2 over 2. So this becomes 2 root 2 into 1 over root 2 plus I times 1 over root 2. So distribute this into the bracket. The result becomes 2 root 2 times 1 over root 2 plus I times 2 root 2 times 1 over root 2. Now this root 2 will be cancelled out. The result becomes 2 plus 2i. So the given complex number z cube will be 2 plus 2i. Therefore, our answer will be A. If z is given as a product of some two complex number, then which one of the following is the polar representation of z? So originally the given complex number is written in Cartesian form. Z is 1 plus I radical 3 times 1 plus I. It's a product of two complex number. Then what is the polar representation of the given complex number? So let this is Z1. Let this is Z1. Assume this is this part is Z2, and we will apply this property. If we have two complex number, Z1, which is expressed in polar form, R1 times cos theta 1 plus I times sin theta 1, and assume Z2 is written in polar form where Z2 is R2 times cos theta 2 plus I times sin theta 2. There is a certain properties. The product of these two complex numbers, Z1 times Z2, which is expressed as polar form, is written as R1 times R2 into cosine of theta 1 plus theta 2 plus I times sine of theta 1 plus theta 2. This is one thing that we need to know. So we will apply this properties of complex number to write the given complex number in polar form. So take Z1. Z1 is 1 plus I times root 3, and Z2 is 1 plus I. So we will try to write this the polar forms of this complex number. So we need to write their polar form. So for Z1, R1 becomes the square root of 1 plus radical 3 square. Okay, 1 square is 1. And for Z2, it's R2 becomes square root of 1 square plus 1 square. So R1 becomes 2. R1 becomes 2 because this thing is 4. And R2 is radical 2. The other thing is the argument for Z1 is theta 1 becomes tan inverse of y over x, which is tan inverse of root 3. So theta 1 becomes 60 degree. And for the second complex number, theta 2 becomes tan inverse of y over x. Here y is 1 and x is 1. Here y is root 3 and x is 1. So we apply these values here. So this becomes tan inverse of 1 over 1 is 1. Tan inverse of 1 is 45 degree. So theta 2 becomes 45 degree. So we do have this thing. So now we can rewrite the given complex number. Z is the product of Z1 times Z2, where Z1 is already here and Z2 is this one. So we will multiply these two complex number in the polar form. So R1 is 2 times cosine of 60 degree plus I times sine of 60 degree. This is our Z1. And Z2 in polar form, it's root 2 times cosine of 45 degree plus I times sine of 45 degree. Here we can apply this rule to get the product of these two complex number. So 2 times root 2 is 2 root 2. Then cosine of 60 plus 45 is cosine of 105 degree plus I times sine of 105 degree. This is the polar representation of the given complex number. So this complex number will be this one. Okay, this is the answer. So from the given choice, our answer will be D. What is the polar form of the given complex number 7 minus I over 3 minus 4I? So here we are asked the polar form of the complex number Z 7 minus I over 3 minus 4I. So before we do anything, we need to write this complex number in its simplified form and in standard form. So let us simplify this thing in standard form. So we multiply both the numerator and the denominator by 3 plus 4i, 3 plus 4i. So this becomes 7 times 3 is 21 plus 28i minus 3i minus 4i square means plus 4 over 3i, I mean 3 minus 4i times 3 plus 4i is the same as 3 square plus 4 square. Okay, always keep in your mind that the product of a complex number with its conjugate is the squared values of the sum of the squared values of the real part and the imaginary part. Now this complex number that can be written as 21 with 4 is 25 plus 28i minus 3i means 25i over 25. So this can be written as 1 plus I. Now the standard form of the complex number, the given complex number is 1 plus I. This is the Cartesian form of the complex number. The question is the polar form. Now when we want to change this into polar form, we need r and theta. R is square root of x squared plus y squared, which is square root of 1 squared plus 1 squared, which is radical 2. So r is radical 2, and theta is tan inverse of y over x. Unfortunately, both y and x are 1. So tan inverse of 1 over 1 is 1. Theta is tan inverse of 1 means this theta should be 45. Theta is 45 degree. Or theta is pi over 4. We have theta and r. R is radical 2 and theta is pi over 4. Therefore, the polar form of the given complex number Z, the polar form of the given complex number Z is equals to 1 plus I is equivalent to Z is equals to radical 2 into cosine of pi over 4 plus I times sine of pi over 4. So the complex form of, the polar form of the given complex number is radical 2 times cosine of pi over 4 plus I times sine of pi over 4. So our answer will be B.